Excited to have everyone here today. I am excited to present part 7 in a series of 10 webinars. We're back on track. I'm Sara Werf. I'm the MDE Math Academic Standards Specialist here at the Minnesota Department of Ed. And we are doing a webinar series on the 8 mathematical practices. The one that we'll be looking at today is Math Practice 6, Attending to Precision. It's part of a series of 8 practices that are in the 2022 proposed standards for our state that will be fully implemented, we predict, in 27-28. As part of those standards, there's 2 dimensions that overlay every single benchmark in our standards. And this year, we're really looking at the first dimension, these 8 practices. Next year, we'll look at dimension 2. Every webinar in this series is posted on a link that I put in the chat that says bookmark. If you're just arriving, hopefully somebody will throw that in there. But you can also get to it with this QR code or bit.ly. I'll share this at the end. There are so many links if you scroll to the second page of this document that link you to recorded webinars and to things called the toolkit. There's a bunch of things I think people are probably sleeping on. There's also a professional learning protocol if you want to use the recording of this webinar with people that aren't here today, and tons of links and resources that you can do. I'm always going to center all of these trainings around the K-12 students in Minnesota. These are pictures that I share in every one of these sessions of members of the committee that wrote these standards. These are the children that will be most affected by this new set of standards. And these standards were written not for the world we currently live in, but the world that they will thrive in. We looked at predictions of what job skills, community skills, college skills that they will need. And there has been changes. And part of that are these practices. And so at MDE, we have 10 commitments to equity. And the one that I'm working on in this webinar series is how do we improve the conditions for learning for all K-12 students in the state of Minnesota? And really the only thing we can control is the actions of the leaders and the teachers and the people that run our school system. So there's small tweaks that I'm going to propose because the math practices describe the varieties of expertise that our students are going to develop, but it's us, the educators, at all levels, starting in kindergarten with greater levels of sophistication into high school, that we are seeking to develop in our students. And today we're going to look at Math Practice 6, Attending to Precision. Here's what this math practice says. If you scroll to the very end of our standards, it defines each of the practices in one of the appendices. And I highlighted some of the words that stuck out to me, and I'm going to try and make these words come alive in the next 26 minutes. So my goal when I'm thinking about attending to precision, my goal of this webinar series is about us, the people in the system. That includes me working at MDE. How do we work to create the conditions for Minnesota students to engage in these 8 mathematical practices? Because they're not going to necessarily arrive having developed these. They have from kindergarten through 12th grade to develop these. The one we're looking at today, I've shown this graphic a lot. It's a graphic from Grace and Amy, where really Math Practice 1 that we started with is our goal, where our students are making sense of problems and persevering in serving them. But all of the other 7 practices serve to help make that happen. And there's 3 drivers of that. One that we've already covered, where students attend to quantities and relationships. And then we have 2 more that are coming out, Math Practice 7 and 8. But Math Practice 6 is one of the 4 tools that we bring to all of these things that drive all of these practices. So we're looking at attend to precision today. And I think when people hear the word precision, we have some biases that are in us about what we've believed that word to mean. Maybe precision is like an incredibly amazing basketball player who can just sink a shot every single time, or maybe you think about calipers and measuring things so accurately and precisely. I think precision comes up in just even some of the silly mistakes us math teachers make. I don't know if you've ever spelled angel when you meant to spell angle. But there's a lot of things that we think about when we think about precision. In Minnesota, we have to attend to precision if we want to go out into our lakes this time of year. Like, we have to know what is the depth of the ice and what are we going to be bringing out onto the ice with us. But precision sometimes doesn't have to mean exact. It can, in this case, there's a range of values that are okay for you to bring a truck out onto the ice. You need about 12 to 15 inches of ice to make that happen. So I don't know if any of you have been out on the ice this year, but hopefully you were attending to precision. I don't want you going in the cold water. There's a lot of jobs that our students might want to pursue as they are in education. And so as we think about that today, what we're really going to look like. So what does precision mean in mathematics? That's what I really want to talk to you about today, because we could talk about that in lots of other contexts, but today we're going to look at it in math. And I think one of the myths of this particular practice is that it's just limited to having precision in how we name our calculations. For instance, if we put a really kind of ugly fraction into our calculators and we get this long non-repeating decimal, do we write out all the decimal points? Do we put ... because that's all the calculator gave us? Do we round this off? Do we think about significant figures? That's certainly a small part of precision, but it's really not the heart of this practice. And so I want to get a little more exact with you. So I'm going to share several different people's thinking on what it means to attend to precision. One of the things that people say that it's really important for you to be precise when you're dealing with situations where a very small error could have a critical outcome. That often happens in finance, like, and sometimes it's a good thing, like a small change in an interest rate over the course of many years can result in a lot more money in my savings account, but it also can penalize me in different ways. Maybe when you're building a bridge, if you're not very precise in calculating the load a bolt can carry, ugly things could happen to that thing. A couple of years ago, someone was trying to visualize the weight or how much $122 billion was, because that's how much money Jeff Bezos had at the time. And so on TikTok, they started with 1 grain of rice being $100,000 and 10 grains of rice being $1 million. And then they counted out 1,000 sets of 10 to make a billion, to represent a billion grains of rice. Well, they didn't want to count out all the individual grains of rice, so they weighed how much the 1 billion did it, and they had to be very precise to make sure they had the whole things there, because as you scale things up, it can get more and more complicated. And so there's lots of ways that we can think about attending to precision. So math practice 6, attending to precision. Let's get started. There's yesterday I asked Chris Jones, who's the Compass math lead, what he thought about math practice 6. He, when the math practices first came out in other states, he was living in another state. And so he had experience as a teacher using these. And he said 2 things to me, and I was like, awesome, I'm on the right track. I've already put this into my session. Dylan Kane, who's a favorite math teacher blogger of mine, said math practice 6, math requires consistent attention to detail. There's so many things that students are juggling, and there's complex reasoning. And we want to develop in our students the ability to juggle all those things, to attend to all the details and express them clearly. So that's one person's view of this. Another person lives right here in Minnesota. Ben Orlin for MCTM made a graphics for all 8 of our practices. You'll be getting full access to those over the next month or 2 if you're attending our monthly Minnesota Math Leader PLC meetings. But the one for this practice, this is a picture that he came up with his little stick figure drawings. And here's what he said about it. In math, we take a magnifying glass to our language. And this was the other thing that Chris Jones said. This practice is really about the language that our students use how precise are they with their language so that they're describing things exactly? What exactly do our words mean? We have to examine them closely. So when you look at those two words, attention to detail and juggling all the complex details that are in mathematics, and then attending to our language and being very precise with it, those are some of the big things that happen. And one of the reason language is so prominent, and this is a Robert Kaplinsky adaptation of Math Practice 6, that mathematically proficient students communicate precisely with others. The word communicate from the big long definition was the one that he pulled out. And he identified 4 specific areas: definitions, defining variables, specifying units, and label axes that are important parts of this. But I really loved this definition of precision. In plain English, we mean it to mean exact, as I mentioned before, and it does mean that, but in math, we extend that definition to also include precision of clarity, precision of accuracy, and precision of rigor. And so I combined that with Robert Kaplinsky's definition, and I'm going to spend the next 10 minutes really unpacking examples of what we mean by precision of clarity, precision of accuracy, and precision of rigor. And then I'm going to end our meeting with teacher moves and what teachers can do to start to build Math Practice 6. So let's look at the first of those 3, clarity. You can go back and read this. I don't have time to go through all of these examples of what it means to have clarity in communication. I'm just going to highlight a few things, and I'm going to start with avoiding vague phrases. So to start with, I'm going to give you a couple videos to look at. Here we go.
Eye on the ball.
You got to keep your eyes on the ball.
Anyways, there's a bunch of those, and they make me laugh all the time. But vague language can also mean, here's a huge one that we use in math all the time, that really, so this is us as educators avoiding vague language ourselves. We'll ask students, what's bigger, a half or a quarter? And the word bigger is really vague because they think about, I don't know if you've met me, but I'm pretty tall. I'm 5'11". And so they'll think, oh, bigger means you're taller, you're wider, it's like literally bigger. When often when we say bigger as a mathematician, what we do mean is not the size of something, it's the value of something, which has a larger value. So one of the things that we want to think about is being really precise with our language and avoiding vague phrases. Another thing that clarity means is defining variables. And labeling our axis. This is a big one with graphs. We often will have a graph like this, and we'll want to make sure our students label the graph, because without a label, who knows what could be going up? We have some numbers here. I didn't mean this to be a slow reveal graph, but it's really important to do this. I have some questions even about this label. I think we could improve it. Age and height of what? Age and height of insects or baboons or teenagers. And our students will often take those and really put imprecise labels on the axes. If we're going to attend to precision, we want to label these things as carefully as possible, because without the word in years, that could be 20 months, that could be 20 seconds, it could be a lot of things. The labels and numbers could be, if it was bugs, it could be 6 centimeters. And so here we have it's in feet. I could improve this graph by adding like the word human age versus height, but being as precise as we can when we're talking about things, particularly things in context. I used to be okay if students just got the word height and age there, I'd let it go as a teacher. But the more experienced teacher I got, I started demanding more precision. Guess what? Students stepped up and they started being much more precise when I would call them on that. And that's where it's our job to really work to develop in our students the ability to be clear. Second part is accuracy. Accuracy has some overlap, and you can go and read these, but I'm going to talk about a couple things. And one that's a little bit of an overlap is defining the units. We saw that a little bit with defining our things, but I got another little video. This time the video is from my family. This is a year ago at my dad's 80th birthday. He just turned 81 this week. And this is my 7th grade nephew last year at his party. You can hear my voice in the background. Good picture of Grandpa turning 80. Yeah. You only turn 80 once.
Well, I guess.
Good picture of Grandpa turning 80.
Yeah.
You only turn 80 once.
Well, I guess you could turn 80 seconds, 80 months, 80 weeks, 80 hours, 80 milliseconds, 80 whatever.
Hashtag unit chat. Thanks, Kayla. On Sara, the math person says, you only turn 80 once. I'm using vague language. And my nephew said, well, it depends what the labels are. My dad turned 80 years old, but my nephew was like, it could have been 80 seconds or 80 months or 80 hours. And I'm like, you're very clever. And I said, hashtag unit chat, because there's literally a hashtag on social media started by Minnesota math leader Christopher Danielson, I think. That's all over, where people call each other out on being precise with the units that they use, being accurate with defining their units. Another part of this is being able to produce exact answers. So precision does include exactness, but there's times for exactness and times for not. And students that I have taught really have struggled with precise exact answers, especially when we're finding like the diagonal of a square and using the Pythagorean theorem. And if we want the precise answer, we leave part of the answer under a radical. And students are like, they just don't even see that as a real number. And same thing when you leave things in terms of pi, but it is precise and exact. And when we type those things into our calculators, we get a precise estimate. And depending on the context, one might be important over the other. Knowing the difference between those will be something else we want to do. Another part of accuracy is thinking about symbols. And so this is a viral math problem that I bet a lot of you have seen. And if you put that viral expression onto TI calculators, these are two from my calculator museum, you can see I have the same expression in each of them, but I have different answers. And part of that is because depending on who programmed the type of calculator, they had a different version of how they interpreted that expression, because that expression is vague. It's not precise. Now, the newer calculators, like this is a Desmos calculator that I screen recorded, what they will do is force you to make a decision. Like, watch what happens with the division symbol in these equations. When you hit the division symbol, it makes a fraction, and then you're forced to say, do I want the denominator to be multiplied by 1 plus 2, or do I want the whole expression of 6 over 2 to be multiplied? And you can see the 1 and the 9. And so helping students understand precision, especially when they're using tools that don't force precision on, Desmos does, but most of the other calculators don't, is super important. By the way, both of these answers could be correct. It kind of depends on what you mean by the vague interpretation there. Accuracy also with symbols, probably the one that gets misused the most is equal sign. I have a lot of information on equal sign here. I've already uploaded my slides in the links that were shared in the chat. Maybe someone will reshare some of the links with you in the chat. But there's, you can go back and read that, but a lot of students really struggle with equal signs. For instance, when you give students, even in high school, this problem and say, only one of these is wrong, they often don't pick the one that's wrong. This one is wrong, but they see this one is correct because they're so used to all math problems are something plus or minus or multiplied by something, and then it equals that thing. They see the equal sign as a do something symbol. So when they see 10 equals 10, they don't see that as a correct equation because, of course, 10 equals 10, because they don't see the equal sign as meaning two expressions that are the same. They have the same value. And so they bring that problem into algebra when they're asked to find unknowns, and they'll often do the thing that's on the right with the equal sign, and they don't see it as this idea of balance. And so that's why they struggle with equations like 12 equals 12 as being true. They see it as false. We have been working in Minnesota Math Leaders this year to really talk about that conceptual understanding must precede procedural practice. And as we've been looking at that, that means bringing in really tangible ways for them to explore things. It also means us as the teachers, if we're going to create this, we're being flexible in how we're using the equal signs in our classrooms and not always putting the unknown on the left side. We can also put that on the right side. Here's a pet peeve. I was a secondary math teacher. Here's a pet peeve of mine in how students misused equal signs. When they were asked to evaluate, they knew how to substitute the 3 in for X into the equation. And so they would just race and start doing that. And then their papers would look like this. Well, what's the problem? If you look at that first part, the value is 9. But if you look at this next part, they found 9 and then they did the next part. Now it's equal to 15. That's not equal. That's unequal. That's an inequality. And so as we looked at this part was 14 because then they were going to subtract the 1. And so on and so on. There, by the way, there is one place where they use the equal sign correctly at the end, but a lot of students will do that. I'll even do it as a teacher. I'll see teachers doing this. And so my trick is if I mean the next step, I will make an equal sign, but I'll put an arrow on it to say it's not an equal sign. Here's the next thing I did, and so on. The third part of being precise is being rigorous. And so I'm looking at my time and I just need to go quickly through this, but it's really making explicit use of definitions, even when it's hard. And I don't know if you know this, you probably know this if you've talked to me. Different states have different definitions of well-known things like trapezoids. Some states like Ohio have an inclusive definition where a trapezoid is a quadrilateral with at least one pair of parallel states. Pennsylvania defines in their standards a trapezoid having exactly one pair of parallel sides. Not the same. So being rigorous is being open to being flexible. By the way, Ohio actually has both definitions as part of their state definition and their state test, assuming that both could be true. Rigorous also means being really meta cognitive and thorough and reasonable and really thinking like, is this always going to work? And so there's this other viral problem that's been going around math world. And I love in the chat, we've had so many debates on the faces are on a cylinder, and there's different answers when you Google that. And so often in math, like we will like want there to be a answer. And so like this problem was asking students to write an addition equation for the multiplication thing. And the teacher marked this wrong. But if you really start to look at when could this be wrong and you think about the commutative property, teachers online haven't agreed whether this should be marked right or wrong. And so really communicating what are the conditions where it could be right or could be wrong is a greater level of sophistication we hope to get students to by the time they're leaving us in high school. So how do teachers attend to precision? Well, one thing you can say to yourself is I can consistently use a model correct content terminology. So let's give an example of that. Saying greater than instead of saying bigger than, saying a length of 5 centimeters instead of saying a long line. This teacher saying sum instead of total, distinguishing between factor and multiple. A favorite of mine is I don't say equals anymore. Instead of saying equals, I will say 2 plus 3 is the same value as 5. I have stopped saying equals because I'm trying to undo the damage of inaccurate definitions. Pam Harris recently posted that she's like, I don't say flip the sign, I say reverse the inequality. So the other thing that's true about that is I know a lot of us who I taught in places of high poverty my whole career and had a lot of students who arrived to me either because of being immigrants or in poverty with low language skills in high school. And I would get scared to use the word coefficient because I'm like, no one's going to answer me. I would like run away from using it early in my career. I would say things like, what's the number in front of x squared? And all my students would get it right, but then they'd leave my class. and they wouldn't be successful with the next people they would see. So early in my career, I started learning a lot about language, and I'm going to be doing a webinar later this year on a secret that radically changed how I became more precise with language. I'm not going to tell you about it now. In fact, I'm going to skip the next couple slides where there's an example just because of time, but look for that webinar on pairing language, because it's one of the best things that I ever did to become more precise. Second thing we can do is expect students to use correct mathematical vocabulary. And sometimes we do that in a bad way. We put up these charts of, if you see these words, you're going to add or subtract. But people who write tests know that. And if you look at this problem and read it, you see a key word for subtraction, take away, except to solve this particular problem, you need to add. And so some of the things we do are actually getting in the way of making things happen. It doesn't matter if we make it pretty or we cut these things out of paper. They're all huge problems. And I've included in the folders, in the resources, there's a Google folder linked, a free book called Nixa Tricks with over 90 tricks we as teachers need to get rid of so that we can be more precise. We also want to be really careful that we don't talk about rules that end. This goes back to the rigorous statement. We might say the shortest distance is a straight line. Well, is that true? Because a lot of the maps we looked at are on two-dimensional paper. And if you look at these two routes, the one on two-dimensional paper that's curved is actually a shorter distance than a straight line. That's because our world is a spherical globe. And so I've also included 3 articles, one for elementary, middle school, and high school, that talk about stop teaching rules that expire after the age that you're teaching. There's a lot of things that lead to students not being rigorous, and it's our fault because we talk about things that work in the moment but won't work in the long term. The last thing that we can do is we can question students, and this is probably my number one tip for you in developing in your students preciseness. A master of this is Minnesota's own Christopher Danielson. He wrote a book called How Many? This is where the unit chat hashtag comes from. And then it's full of lovely pictures like this one, where you'll ask students how many, and they might say there are 8 pits. They might say there are 15 half avocado. They might say there are 7.5 full avocados if you put the halves together. They might talk about there being 1 or 2 cutting boards, depending on how you see that picture. Here's another picture. A student might say there are 7 small pumpkins, but giving students experiences, and pictures are a great way to do it, and simply asking how many. Students might talk about how many floorboards there are. Being precise and labeling what you're talking about is super important. So I'm going to end with a story. This is what I'd love to see all of us do in our classroom. This comes from my friend Berkeley Everett. One day, a second grade teacher saw this student work. And often in math, we go after, oh, they have the wrong solution. That should be 6. Why did they put 75? And we look at what's wrong with it. This teacher, was thinking, how am I going to address this student? And this teacher had been well trained with my favorite discussion supports, which are a series of students, rather than asking about answers, asking about reasoning. And so this teacher presumed competence in their student and knew that it was important for this student to be even more precise. So this teacher asked the student something like this: I'm curious, what are the numbers in your equation? What do they mean? Can you tell me more about the numbers in your equation? When this teacher, second grade teacher, asked the student said, well, I have 5 dimes and 1 quarter, and they equal 75 cents. So then the teacher worked with that student, here's the piece of student work, to become more precise in how they wrote their solution. You can see that the word dime and quarter and 50 and 25, and there's a cent sign that went into the problem. And this is based on the context, and context matters with precision, because depending on the context, students may or may not need to be precise. Like, I don't know what's up with this road sign. I don't think it needs to be 96 hundredths of a mile ahead. I think they could have just said 1 mile. And I'm like, who literally is going to count 1,036 persons in a space? But there are signs that I think it's okay to be this level of precision. This is at our state fair, about a foot long. No one is carrying a ruler at the fair and actually measuring those things. And so the context matters. When I say 5 minutes and you're taking a test, it's probably going to be exactly 5 minutes till I tell you you're done. But if my teenager is upstairs saying, I'll be down in 5 minutes, that could mean anything from 2 minutes to 25 minutes from now when they will be down. 5 minutes, context matters. Here's another difference. My teen daughter's bank account is way less than mine, and they need to be very exact and precise so that their debit card doesn't get declined. But my mom budget, they can estimate costs a little more because I have a little more of a cushion. And so I don't need to be as precise when I'm going to Target and thinking about things. I also really recommend using current event context. I used one from this week. They're talking about getting rid of pennies. And no matter where you stand on whether they should or should not, there's so many interesting questions about precision. Like, would we have to like everything at the store, would we reprice this? Or like, how would we round if there wasn't pennies? Would we round up to the nearest nickel? Would we round down? There's really interesting things where we can develop conversations. I also have 576 math fails on my website that I link to and actually put in a folder for you, so you don't even have to go to my website, that are all these pictures on 8.5 by 11 sheets of paper where there's some kind of fail in, most of them are fails in precision of the person where they made a math mistake. This is a classic one that we see a lot. That's a picture that I took at Hy-Vee one day. So there's a lot of things that we can do. And so I put in some lists of these things. And I've also talked about when precision's not necessarily necessary. You can go back and take a look at that. But it is 4:32, and I want to get you out of here today. And so I want to remind you at this bit.ly, you can find all kinds of things at this bit.ly. And I want to just remind you, when you're looking here, you will find a folder. In the folder are all kinds of things, like all those math fails that I talked about. Those articles on rules that end are linked. But there is also like a link in the PLC protocol, if you scroll down, to all these articles and a toolkit. Don't sleep on the toolkit, because the toolkit not only defines it, but it talks about what it looks like in kindergarten, first grade, second grade, and so on. It has rubrics for teachers, grading, and students, and a parent guide. All of my webinars have come with that. And so I just really recommend taking a look at all of those things. So thanks for coming today. I will stick around for a few minutes, and have a great day.